And let's work through some of these together. This uses stuff that we know. It serves as a review. Let's phrase it that way. It serves as a review. So let's try number 1 together. Let's just see how far we get. Let f be a continuous function. Oh, with f of 2 equals negative 1. So let's put that point on there. F of 2 equals negative 1. All right, so that means the point 2, negative 1 is on my graph. Sketch a possible graph for f given this information about f prime and f double prime. What does f prime tell us about the graph? Let's just back up a second while we're reviewing. F prime tells us the slope, and f double prime tells us concavity. Okay, so number 1, when x equals 2, now let's start with on the left. When x is less than 2, the slope is positive, the concavity is negative. So before we try to put this on a graph, let's try to draw a little picture right here of a piece of a graph that has a positive slope but concave down. So positive slope but concave down. So I want to be increasing but frowny face, right? Concave down. So increasing but frowny face would look like that. At x equals 2, again, I'm not going to the graph yet. Slope is 0. What does that mean? Yeah, perfect. Horizontal tangent line. So it's going to be flat at that spot. Concave down still, so that looks like that'll be a maximum at x equals 2. And then greater than 2, a negative slope with a negative concavity, so decreasing concave down, something like that. So I want to put those 3 like pieces of the graph together, but they have to go through this point. So something like that. Okay, back up to the directions. On 1 through 5, they all 5 of those have the point 2, negative 1 on them. So I can put that point on number 2. Okay, left of 2, slope is positive, but I'm concave down. I'm going to add a little column here or a row to do a little mini picture. So see if you can sketch something. Don't worry about on the actual graph, but sketch a little piece of a graph in our added box here that has a positive slope but concave down. And then on the right-hand side, sketch one that has a positive slope but concave up. All right, most of you have already tried them, but try 3, 4, and 5. So I'll hit pause. I'll do 3, 4, and 5 up here. Anything else on 3, 4, 5? 6 is kind of a backwards problem, I guess. I don't know. I feel like 6 is easier. We should put 6 first. They give you the picture, and you're filling out the table. So you know what? Instead of me talking, yeah, a graph from a graph. Again, be careful about what they give us. The graph of the derivative is given, and this may seem like overkill, but I'm going to go ahead and label this graph anyway. Because the big mistake people will make is their brain will think this is the graph of f, and then they'll answer questions, and they'll answer them all right, but you started out wrong. So you've got to convince your brain that this is the graph of f prime, and then we can answer questions. Determine the intervals where f is increasing or decreasing. Justify your answer. Okay, f is increasing. How do I know when f is increasing? Like, what would I be looking for? What would be true? I want to know where f prime is positive. That shouldn't be equal sign yet. F is increasing where f prime is positive. So I look at my picture, Leah, and where is f prime positive? Good, because this is the graph of f prime. F prime is positive from -1 to 2. F is decreasing where f prime is negative. Again, be careful what you're looking at. Barrett, where is f prime negative? Yes. Part B, determine the intervals where f is concave up or concave down. Okay. Sophia, how do I know where f is concave up? Like, what is true when f is concave up? And you don't have to, not even look at that picture, just tell me something about f being concave up. That's a great place to start. The second derivative is positive. That is a true statement. It's not enough to justify from this picture because I don't have a graph of f double prime. So it's true and it's helpful. It's just not helpful enough yet. So if f double prime is positive, what does that mean about f prime? It's increasing. So I want to know where f prime is increasing. Now that's more helpful because I have a graph of f prime. So Audrey, looking at the graph of f prime, tell me where f prime is increasing. Yeah, give me the interval. Good. And if f prime is increasing, that means f double prime, which is the slope of f prime, is positive. And if f double prime is positive, then we're concave up. So it's making those connections. Graham, where is f concave down?
Whenever f double prime is negative.
Okay. You can skip that step if you want to. If you want to go straight to the end, what would you say about f prime?
It's decreasing.
It's decreasing. Now, a lot of people will continue to write that because that's the first thing they think of when it comes to concavity is second derivative, which is probably good. You probably should have that as the first thing you think of. But if f double prime is negative, that means f prime is decreasing. So, Isabel, I look at my graph of f prime, and where is f prime decreasing?
1/2.
Good. Now for the fun part. Sketch a possible graph of f of x. Now, we do get a starting point up here. F of 2 equals 3. So I know that my point on that graph is 2, 3. And let's see. We are increasing from, or no, I'm trying to go in order here. We're decreasing and then increasing and then decreasing if we put these in order. Although I have a point. We're decreasing from 2 over, so I know I can do that part. And I know I'm concave down there, so I'm good there. There's a, what do we call this point at 1/2 when it changes concavity? there's a POI at x equals 1/2. I guess the trouble is we don't really know where that is, so somewhere in here we change from concave down to concave up. And this still matches with f prime is positive from -1 to 2, so that, something like that. That's the trickiest thing we do in my mind in this unit, is taking a graph of f prime and drawing a graph of f. And it said possible because we don't know exactly where these points are or how steep this graph is. So our graph could have looked like that, and that would still be okay because it still has the minimum and the maximum and the point of inflection at the same spot. So that possible graph is what's maybe a little bit tricky. Number 8 is the same thing as number 7, so I'll leave that one for you to do. Number 9 through 16 is the same thing as we did on 1 through 5, like where you have to sketch a graph based on information. It just gets a little bit crazy because, like, if you look at number 12, like, that's a lot of information to incorporate in your graph. So that's a little bit weird. There's also some limits on there. We got time. Why don't you try 9 and 10? By the way, today's assignment is through number 14, so we'll have done a big chunk of it together. So try 9 and 10. Number 10's got a little more information there. Again, I start with f of 1 equals -1. And what else do I know? So f is increasing when we're greater than 1. And the slope, actually I have an actual slope. The slope is -1 when we're less than 1. So like that's not just that's more information than we usually get. Slope is -1, less than 1, that I can draw. Okay, on the right-hand side, though, I need to be increasing. And what does this mean? Limit as x approaches infinity of f of x equals 3. What does that mean my graph is doing? So I need to be increasing. That means there's a horizontal asymptote at 3 that I need to be approaching. So I don't really know how I get there. I mean, I assume it looks something like that. Barrett?
Would you have to do something at the bottom so that it's not a cusp? Because you can't have a derivative of this cusp.
Yeah, but it never tells me that anything about the derivative at 1. Right? I mean, you're right, that's a cusp, and I should be worried, but it never said that the derivative at 1 had to be anything. So, yes, there's a cusp there, but that's okay. Okay, the rest of those. Do you want to try number 12? Some of you are like, nope, don't want to try number 12. Try number 12, and then I'll do 12, and then I'll stop. But maybe it seems helpful. For the concavity stuff, when x is less than 3, we're concave down. So we're concave down this whole over there, and concave up over there. So maybe that helps to put that, like write it on the graph. So I need to be increasing but concave down, and then decreasing concave down, and then increasing concave up. So something like that. I mean, if you can do that one, you got it. Like that's the hardest of the bunch. Okay, so today's assignment is to finish this worksheet. That's not hard. I would say also start some of worksheet 5 because that's the review. And we won't have time to do all of those tomorrow. So, yeah, there's a bunch. Oh gosh, that's a ton. So I will probably not assign all of them, but I would take a peek ahead. In fact, I'll just tell you now, so if you want to start ahead, I'll only assign the odds on worksheet 5. And then we'll work some of those tomorrow as well. So finish worksheet 4, that should be easy, and I would try some of worksheet 5 so that you're ready to review tomorrow.